Hi and Assalamualaikum. In this video, we're gonna talk about valence bond theory of H2O. To start off, I will tell you the three objectives that will be achieved in this video. The first one is to explain the type of covalent bond, which is sigma and pi bond present in the H2O molecules. The second one is to describe the orbital overlap involved in the formation HO bonds. The lastly is to analyze the hybridization of the central oxygen atoms in H2O. In the introduction, we have two components, which is definition and concept. Let me look at the definition first. So, what is valence bond theory? Valence bond theory is a quantum mechanical description of chemical bonding in which a covalent bond forms when two atomic orbitals overlap and the electrons are localized between the bond's atoms. For the molecule that we study, which is H2O, valence bond theory defines the bonding in H2O as arising from the overlap of oxygens, sp the power of 3 hybrid orbitals with oxygens 1s orbital, resulting in localized electron pair that form 2 OH covalent bond and 2 lone pair on the oxygens. Now, we look at the concept of valence bond theory. Valence bond theory is present as one of the two foundational theories of bonding, the other being molecular orbital theory. It emphasizes localized electron pair as the basis of the chemical bonds. The next one, it explains molecular structure using hybridization, mixing of atomic orbital to account for observed geometries. It uses resonance to describe molecules that cannot be represented by a single bonding arrangement.
H2O molecule contain covalent bonds, which are formed when atoms share electrons. There are two types of covalent bond, which is sigma bond and pi bond. A sigma bond is formed by the head-on overlap of atomic orbitals, such as s and p orbital. This type of bond is very strong and stable, and it is present only in single bond. A pi bond, on the other hand, is formed by the side-by-side overlap of two p orbitals. Pi bond exists only in double or triple bond. A double bond has one sigma bond and one pi bond, while a triple bond has one sigma bond and two pi bonds. This shows that a sigma bond is always formed first before any pi bond. So, what type of covalent bond that present in H2O molecule? The H2O molecule has two sigma bond and 0 pi bond. Each OH bond is a single covalent bond, which is a sigma bond formed by the head-on overlap between the hydrogen 1s orbital with an oxygen sp3 hybrid orbital. There are no pi bond in H2O because pi bond require side-by-side overlap of unhybrid p orbital. Oxygen orbital in H2O are all sp3 hybrid, and hydrogen only has a 1s orbital, so pi bond cannot form in H2O molecule.
I will explain about what it is hybridization. So hybridization is to explain how the atomic orbital meets to form a new hybrid orbital that used for bonding molecules. It also to help us to understand the shape of molecules such as linear, tetrahedral, trigonoplanar, and so on, and also bond angles of molecule. So why it is happen? So it is to form a stronger and more stable bond with the correct molecular geometry. So I will show the step from molecular formula to hybrid orbital. So, firstly, we have to write a molecular formula and find the total central atom. The next one is we have to sketch the Lewis structure to help us to understand how much the bond and how the electron was arranged. The next one is we have to apply the alpha principle. Lastly, hybrid orbital was occurs. So, this is the example for hybridization for water molecule. So, firstly, look at the molecular formula, which is water H2O. So, each hydrogen atom contribute 1 electron. So, the 2 hydrogen give 2 electron. So, the oxygen contribute 8 electron. The total electron is 10 electron for the water molecule. So, the next step is sketch the Lewis structure. So, in the Lewis diagram, oxygen is at the center that bonded with 2 atom hydrogen by a single bond. So, oxygen also have a 2 lone pair that show as a dot. So, the molecular shape of this molecule not linear but a band shape because it have a lone pair. Next, we move to the electron arrangement. So, according to Alpha principle, electron will fill the lowest energy orbital first before move to the higher energy level. So, for oxygen, electron configuration is 1s2, 2s2, 2p4. And lastly, hybridization method. Oxygen undergoes sp3 hybridization. So that means that 1s orbital and 3p orbitals that combine to form a 4sp3 hybrid orbital. I will explain how the hybridization is occur on the hydrogen molecule. So, I will explain. On the left side, we can see the ground state of the oxygen atom. So, oxygen have electron configuration which is 1s2, 2s2, 2p4. So, in this diagram, 1s orbital is fully filled with the electron, and then 2s orbital have 2 electron, and then 2p orbital contain 4 electron. So which is 1 lone pair and 2 unpaired electron. So before the bonding happen, oxygen orbital undergo the hybridization. So 1 2s orbital and 3 2p orbital will combine to form 4 sp3 orbital as shown on the right side. After hybridization, this water molecule contains 2 lone pair and 2 unpaired electrons. So that's why sp3 hybridization explains why the water molecule has a band shape with 2 lone pair pushing the hydrogen atom closer together.
Water is formed from 2 hydrogen atoms and 1 oxygen atom. Each atom has its own set of atomic orbitals, which are regions of space where electrons are likely to be found. Each hydrogen atom has 1 electron residing in it as atomic orbital. This orbital is spherical in shape, while oxygen undergoes hybridization to form 4 sp3 hybrid atomic orbital. Hybridization is the mixing of atomic orbital to form new hybrid orbitals suitable for bonding. These sp3 orbitals are arranged in a tetrahedral shape around the oxygen atom.
In water, each hydrogen atom shares its electron with one of the sp3 hybrid orbital of oxygen. This overlap creates a sigma bond, which is a strong covalent bond. Because oxygen has 2 hydrogen atoms, 2 sigma bonds are formed. Oxygen has 4 sp3 hybrid orbitals, but only 2 are used to bond with hydrogen. These remaining 2 sp3 orbitals are contain lone pairs of electrons. These lone pairs are not involved in bonding, but play a crucial role in determining the shape and properties of the water molecule.
So, for the conclusion, in summary, the valence bond theory helps us understand the bonding in a water molecule by describing how atomic orbitals overlap to form covalent bonds. In H2O, the oxygen atom undergoes sp3 hybridization, resulting in 4 hybrid orbitals, 2 of which form sigma bonds with hydrogen atoms, while the other 2 hold long pair of electrons. This orbital arrangement explains the band molecular geometry of water and its bond angle of approximately 104.5 degrees. Valence bond theory effectively illustrates how orbital overlap and electron pairing contribute to the shape and polarity of the water molecule, making it a powerful tool for interpreting molecular structure and behavior.